Welcome to day 13 of the macOS and iOS Security Internet Advent Calendar. Today we will be looking at sandboxing, but only from the point of view from user land. So we will not dig into the kernel functionality of the sandbox. So sandboxing is, however, completely implemented at kernel level. And so the idea how this works is it's based on the Mac framework that we discussed yesterday. And the idea is that all the sensitive kernel functions are hooked, and the sandbox kernel extension will then provide a Mac policy that hooks everything and basically applies the sandbox profiles to all of the hooks. Like I said, we will not go into detail here how this actually works. That is a kernel land topic. We will only look at the userland view here. So the idea here in this system is that processes can optionally run in a sandbox. They don't need to, but in the interest of step, Apple added basically a whole sandbox around the whole system, and this platform, this sandbox is called the platform profile by Apple. So there's one sandbox around everything. One word of warning here, this slide deck will only cover stuff up to iOS 15, so changes that we see in recent iOS 16 and macOS Ventura are not covered by this here yet. So yeah. Okay, so look at the following graph as example how sandboxing looks like. Basically we have processes on the system, and those processes here, they are completely unsandboxed. They have no sandbox profile applied to them. Then we have the green, the blue, and the pink, purple processes. And the color of the circles basically says what sandbox profile are these running under. And this is basically to visualize that processes can have sandboxes applied to them, and several processes can run under the same restrictions, and other processes have their own specialized restrictions just for them. That's the idea. At the same time, the whole system is put into an own sandbox, and as you can see here, everything is basically covered by that, even the processes that are normally not sandboxed. When you look at the implementation, you will realize that, of course, on the lowest level, there's a binary parser that parses binary sandbox profiles. But all these binary sandbox profiles are generated by having a specific sandbox language here. This here is an example how one of those files could look like. On macOS, you will find sandbox profiles in, for example, system library sandbox. There are some profiles in these directories or in the subdirectories. On iOS, usually you don't find the plaintext profiles. So how do you read these profiles? First of all, this here defines the version, which in this case is version 1. They can also import other sandboxes. And then they have a default action here, and the default action is to deny everything. And that means it's basically a whitelisting sandbox, because by default everything is forbidden. And then there's the whitelist of things that the process, in this case syslog-d, can do. And what we can see here is we have these actions deny, and the other action is allow. There are also some modifiers for that, but they don't matter right now. So we can deny or allow certain things. And then the next thing here is what operation do we want to allow or deny. And this here was a default operation, so that's everything that has no specific rule. And then we have operations like mac lookup, file read data, file read metadata, file write. So apparently this year is allowing certain kinds of file writes and reads. And now the question is, where is this allowed? And this depends on the filters that are applied in each sandbox rule. And here this is a regex filter, and a normal regex filter filters in this case the file path. So the file path will be evaluated against these three different kind of regex, and only if it matches any of those the whole thing will be allowed. And that's basically how you read and understand these plain text sandbox profiles. So now the question is, what operations are there and so on. So when we look into that, and also what filters are there, when we look into that, we can see throughout different iOS versions and so on that we have a long list of operations, but it keeps growing with newer versions. And this is one of the reasons why I said this year only covers up to iOS 15, because newer stuff is basically not covered by this slide deck. So here you can see we have a wide variety of stuff that we can filter with a sandbox. For example, we have all the different kinds how you can access files. We have things like change routes. We have process forks. We have process executions. We can, when someone tries to get code signing information, we have stuff for that. We have stuff for accessing process info via usually the proc info system call. We have IPC communication. We have IOKit communication, so talking to drivers, and a lot of other stuff. Dynamic code generation, for example, is controlling who can do map-JIT, so who can have RWX memory in their process. Since iOS 13 or so, you can also filter syscall Unix, and since iOS 14, you can filter syscall mach. So you can basically filter also that certain system calls are not allowed, or certain mach traps are not allowed. The storage class map is a special thing. This is usually a sandbox profile that takes a file path, and the idea is that for a given file path it will tell you what kind of storage class it is. For example, we tell you, oh, these are calendars, this is email files, this is a download folder, this is the documents folder, this is the desktop, and so on. And by putting stuff in different storage classes, you can write easier sandbox rules. Like, for example, you can allow an email software to access the email folder, but everything else, for example, has no access to that emails, and so on and so on. So as you can see with newer iOS version, there's new operations that get added. And what Apple did here was they added more fine-grained control over the process code signing information. So now it is easier to control what part of the process code signing information a process can access. But you can also see that they added new filters for FCNTL system call parameters, and for actually getting and setting socket options. Usually Apple adds these things on demand when they need a certain feature, and then they basically add a bunch of new sandbox operations. So here you see at this point there were file system quota limits that get added with the iOS 14.6 and 14.8. And when we go even further, you can see we have now more fine-grained control over IOKit. The reason for this is that the problem with IOKit rules was that when you filter by the type, what happens is that a driver is still opened, and the driver is told to create a so-called user client. and only after that the sandbox would say, oh wait, this user client should not be accessible by this code. But of course at this point the user client is already created, and that maybe has unwanted side effects. And so Apple added stuff that you can actually filter what services are allowed to be open and stuff like that. And so this happens actually before the user clients are created. Also nowadays in iOS 15 there are these binary versions of code signing blobs, of entitlements and code signing blobs, the dir entitlements. And so there's new stuff for that, and so on. There's also now you can have filters on the Mac syscall. Mac syscall is a special system call for the Mac framework, and yeah, so on basically. Yeah, and here you can see there's more stuff, but this is usually stuff you will not see so often. Okay, so that was the operation, but there's also a list of filters that you can apply to each of these operations. And usually the filter is somehow connected to some of the operations, like for example, the fctl command filter is likely used together with the sysfsctl system fsctl operation and so on. In other cases it doesn't make so much sense. You also have the boot arg argument. This is likely for the boot arg set operation and stuff like this. And also of course with newer versions there's newer filters added. Here for example we have the fcntl command and the socket option level and name, which is also no surprise because in this version of iOS they also added the operations that are matching here. For iOS 15 there's also new filter types. That is basically that. Yeah, so this slide deck only talks the whole time about iOS. The thing is, for macOS the filters and the operations are usually mostly the same. There may be sometimes slightly different between point version, because then macOS maybe has a filter or an operation that iOS doesn't have yet, or the other way around, but in general they are the same. So now something that is unique more or less for iOS, because in iOS you have no plain text profiles. So there's actually a huge archive of all the built-in Sandbox profiles for all the processes that need them in iOS. And here you can see all the names of all the built-in profiles. So macOS has also built-in profiles, but they have like a handful or so. Like for example for driver kit and so on, they have their the userland drivers, what sandbox they are in. I think it's called com apple dext. That's a built-in profile, but for iOS we have far more of these profiles. So as you can see here, for example, there are a bunch of WebKit profiles. So for example, for the WebKit renderer, and the container sandbox is where all the apps run in that you download from the App Store. And then many of the other things are basically have the same name as some daemon that runs on iOS in most cases. So you already know from the name of the Sandbox profile usually what is running inside this profile. Of course, with newer versions there's new features. Apple puts new daemons on the system with sandboxes, or they put new sandboxes on old daemons. So you can see this is the difference between those two iOS versions. And then with iOS 15 we have the same thing again, and yeah. Okay, so that is this. So, oh yeah, it's even more, so the more new versions of iOS. Anyway, so there's a new filter feature in, I think, iOS 14, where basically you can not only, I told you, you can have filters on system calls and Mach traps, but you can also have filters on Mach messages and IOKit messages and asynchronous messages and XPC messages and so on. And normally that would be a little bit problematic in the system how to implement this, and this is why they have this addition to the Sandbox, which is the message filters that can be applied to certain Sandbox operations. Here, for example, you can see Mach bootstrap is allowed, but it will apply a message filter, and it will deny Mach message sent with telemetry. So if the Mach message sent was denied, it will have the telemetry logging, and if the Mach message sent will be allowed, it requires that the message number is one of those here. So basically that there are Mach messages, and the Mach message internally have a code number, and these are the code numbers that are basically allowed, and only those will be then allowed. And yeah, previously that was not possible. Previously you could only say, oh, I either allow Mach messages to be sent to a Mach server, or I don't allow it. But now you can have fine-grained control what Mach messages should be allowed. And here there's also XPC message send, that's for older versions. Yes, so but that's just a renaming in the Sandbox profile. So the following filters are available since iOS 14. So we have the default filter, then we have an IOKit async external method, IOKit external method, IOKit external trap. So this is for different kind of messages, or better say routines, that you can trigger in IOKit drivers. So there is this feature that IOKit drivers can add Mach traps to the system. They are called the external traps. So now you can filter exactly what external trap numbers can be executed by the Sandbox process or not. The normal methods that a userland code triggers in an IOKit driver is via IOKit external methods. And here you can now specify that it's not only allowed to call external methods, but you can specify exactly which of those are allowed. When it comes to external methods, there's the normal external methods that are synchronous, and there's the possibility to have asynchronous external methods. And therefore there's a separate message filter so that you can specify what asynchronous external methods can be executed. And what we just saw is Mach message send and XPC message send. So these are special filters so that you can basically control which XPC message and which Mach message can actually be executed. Previously you could only allow all or none. So Sandbox Profile selection. So basically when you download stuff from the App Store, it's in the container directories, which will more or less force the stuff to be executed in the container sandbox. And platform apps, so these are the command line apps, for example on iOS, they usually choose their Sandbox profile via an entitlement. They can also, for example, choose their Sandbox profile themselves by running functions in libsandbox, but usually they have entitlements that tell us what Sandbox profile they run in. And basically this is called the seatbelt-profiles because the original code name of the sandbox was seatbelt. And yeah, in this case we know it's running in the game D sandbox. By the way, for iOS I once created a tool that spits out something like this here. So this is the output of PS, where you not only see the normal output of PS, which is the user that runs the process, the PID, the parent, the group, and the comment and time and so on, but it also spits out what sandbox a process runs under. So here you can see the name of the Sandbox profile, the built-in profile for a certain iOS sandbox. In most cases you can see that the sandbox name here is the same as the daemon name, but here, for example, air traffic is the ATC daemon, and so on. This is for a few slides, so you can see the difference that exists here. Sometimes you would realize that on a newer version there's suddenly a daemon that is suddenly under a sandbox that was previously not, and so on. Another way how you can find out if a process that is running in a sandbox or not is, of course, there's the console app, not the console app, the system information app in macOS, where you can see if something runs in the sandbox or not, but usually just tells you, oh, sandbox or not. If you want to know what is the what is the sandbox profile that it runs in, one thing you can do is you take the process ID and run launchctl proc info on the process identifier. You get back this kind of information here, which tells you, like, for example, of course, the BSD information, like what is the user ID and group ID and so on of the process, but it also tells you the entitlements of the running process. And here in this case, we have the seatbelt profiles that tells us, oh, okay, this process runs in this sandbox. Of course, that only works on these processes that get their sandbox from the entitlements. If it's one of the processes that at start basically calls lib sandbox and tells it what sandbox it wants to use, then this doesn't work. But in this case here, it works fine. Yeah, and that's it for the userland overview of what the sandbox is. Yeah, as I said, if you want to learn about how the kernel part works, we need way more time than the advanced calendar, so you need to go to a full training basically. And then you see everything, how it works in the kernel, how you can extract it from the kernel, and so on and so on.